All right, so we got to pick up a little bit from yesterday. We have this grid. It's on page 10 in your notes. It's the last page on 6.3 notes. And I just wanted to make sure you guys had that. You guys did have that, but one of my hours didn't. And I just want to make sure it's covered. And then the bottom 6 questions we were supposed to just kind of go through and get done. Maybe perhaps it's taking its time. It's thinking still. Alrighty, come on. Thank you. Okay, so question 7 talked about, can you prove that the quadrilateral is actually a parallelogram? Notice you have a 4-sided figure and you're supposed to go through and go, hey, is it a parallelogram or isn't? The grid that you just copied down is really a list of answers for you to connect with the question itself. So here I got opposite sides are parallel. Opposite sides are parallel. It is a parallelogram because by definition of parallelogram, opposite sides are parallel. Now you'll notice that in the answer, I am kind of throwing back the properties I'm using because this is notes, and notes is reading. Your notes should help you understand the material. It shouldn't be a reconfiguration or refigure of the material or relearning because you didn't get it done the first time. Now, opposite sides are congruent. Theorem 6.8, yes, opposite sides are congruent. It works. It's a parallelogram. Okay, opposite angles are congruent. Well, heck yeah. Which one's opposite angles? Which one of the numbers we got for opposite angles? You guys got it right there. You got opposite angles. Isn't it 610 as we go through? 610, yes, opposite angles. Are you okay with how this should be working? Okay, now I've got opposite sides on this next one. Well, that was theorem 6.8. Yes, opposite sides are congruent. This next one, I have diagonals are bisecting each other, and I get diagonals bisecting each other from theorem 6.11. Okay, so I've got theorem 6.11, yes, diagonals bisect each other. And my last one set of sides is parallel and congruent. Please notice it's the same side, it's parallel to the other side and congruent to that side, and it's theorem 6.12. Okay, yes, one set of opposite sides are parallel and congruent, or congruent and parallel. So that's the information that we covered in 6.3, okay, our converse of information. Now today we're looking at theorem 6.4. We're doing special quadrilaterals, okay. They are beyond the information that we've talked about today, and we're going to cover some other special ones on 6.5 next year. So, you know, it's going to be a while until we get to those, January 2nd. So, what we're looking at today were special types of quadrilaterals, or rhombus, rectangles, and squares. You're going to learn today that rhombus properties, diagonals are perpendicular to each other. Diagonals bisect pairs of opposite angles. All sides are congruent in a rhombus, and squares are rhombuses. You're also going to learn about rectangles. Rectangle properties are diagonals are congruent, interior angles are 90 degrees, and squares are rectangles. And you're going to learn that squares is the most specific shape we have. Keep in mind, rhombus, rectangles, and squares are parallelograms, so they're going to have all the properties of everything else that we've worked with so far. So our very first thing on page 11, at the top of page 11, we're doing rhombus, rectangles, and squares. Oh my. So go ahead and get that stuff down as I read it aloud. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles. So a square is a rhombus rectangle. Really what it comes down to. Now this sometimes, always, or never section, okay? Looking at this special parallelograms Venn diagram, okay? Now, you have rectangle properties, you have rhombus properties, and there is a sweet spot where both those properties are squares, okay? You're going to answer sometimes, never, or always. A rhombus is a rectangle. Sometimes, when it's a square, right? A rhombus is a rectangle when it's a square, so sometimes, okay? A parallelogram is a rectangle. Parallelograms is the big area. Rectangles is a subset of parallelograms, so sometimes, okay? And parallelograms are sometimes rectangles when those parallelograms have interior angles that are 90 degrees. Okay, so a rectangle is a square. A rectangle is a square. A rectangle is a square. Now, I know a square is a rectangle, but not all rectangles are squares, and we can see that from the Venn diagram, so that's sometimes. A square is a rectangle, always, as we look at that Venn diagram and talk about it. Remember, all the properties we talked about, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, consecutive angles are supplementary. All of those properties of parallelograms are also held by rhombuses, rectangles, and squares. They just have more properties than the regular parallelogram. That's why we're studying them more. Such as diagonals are perpendicular to each other. So write that down. Thanks, kiddo. Now, as we're going on in notes, you guys can look at that next one and see where things are bringing us. But today's objective, to define and classify special types of parallelograms to use properties of diagonals of rhombuses and rectangles. And remember, those special properties are up here on the sideboard. We're talking about rhombuses, rectangles, and squares. Rhombus properties, diagonals are perpendicular. That's what we're looking at right now. Diagonals are bisect pairs of opposite angles. All sides are congruent in a rhombus, and squares are considered rhombuses. Okay. Now, rectangle properties, diagonals are congruent, interior angles are 90 degrees, squares are rectangles. So I'm going to keep coming back to that so we make sure we drill that into our little brains because we got to get that done. Hey, look, same thing we just wrote down, and then we got theorem 6.14. A parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So we know this to be true. Now, keep in mind, all the rules of triangle sum theorem comes together on this. All rhombus diagonals are 90 degrees. So I know these interior angles here, these puppies right here, are 90 degrees, okay, a piece. Angle 1 and 2 are the same, and so is 6 and 5. 6 and 5 and 1 and 2 are identical angles, because remember, in a parallelogram, opposite angles are congruent. Half an opposite angle that happens to be congruent should be congruent as well. So it's kind of there are 4 angles here that are congruent along each diagonal. So of the 8 angles, when they're cut in half of them are congruent to each other. Okay, so keep that in mind. Answering questions with that idea. You have knowledge. You have notes. It must be knowledge. Everybody assumes they have knowledge when they have notes. Let's see what you know. 2A. Go ahead. Get after it. Get after it. Remember, we're working with right triangles here. And we're given the fact that this is a rhombus. All the sides are the same. The angles are perpendicular to one another, so I already know angle 1 is 90 degrees. Okay, I know angle 3 and angle 2 are the same. They're both 58. I know that the acute angles in a right triangle add to 90. So 58 plus 32 is 90 degrees. Okay, thank you, sir. Are there any other questions about this? Are you okay with this? Any questions why angles 2 and 3 are 58? Okay, now remember, I just want to emphasize this. The diagonals, if it ever comes up, the diagonal of a rhombus bisects this angle. This is a parallelogram. This angle and this angle are the same. They're 116 degrees. I know that because half of it's 58. Well, angle 3 and angle 2 make 116 degrees, half of which is 58 apiece. That's where it's going. I could also talk about alternate interior angles and with 58 and angle 2, but then angle 3 is the same as angle 2 because they are bisected by the diagonal. Okay, 4 and 3 must add up to be 90 degrees. Okay, so that's another reason why I know the things I know. Now, with that information about rhombuses, get after B. Go ahead, go for it. Excuse me, dear. Yeah. Sure. Sure. Just put it on my desk. Yeah, just put it on my desk. Thank you so very much. Yeah, thank you very much, you guys. Appreciate it, kiddo. Have a great day. Okay, so here's the deal we've got going on. We got these as 38 degrees. Are there any questions how I did it? I got some people shaking their head. I've got some people looking at it like they're mean and mad at it. The mean and mads are pretty much like, I don't know how it happened. I'm upset. Okay, so let's talk about it for a second. Are you in agreement that since this is a rhombus, this is true? Are you further in agreement because this is a rhombus, the diagonal is bisecting my opposite angles that are congruent, so all those angles are the same. Now, I know all that before I start thinking, well, it's 38 degrees. But now, let's boil it down to an isosceles triangle with vertex angle 104. Are you okay that that's 76? Now, I have 76 degrees left in a triangle to share between two angles. 76 divided by 2 is 38 degrees. Are you okay with where I'm going? Okay. I'm just using triangle sum theorem with the idea of base angles of an isosceles triangle to make my question a little bit nicer and easier to see. And that's how I'm doing it. Okay. Any questions? Now everybody's happy with that question. It's like that question just gave them a gift, and they're thinking about, oh, how do I write a thank you to a diagram? Okay, what do you have? On A. So you're okay with B. So A, which one are you looking at? All or just parts? Okay, which part? Say that again. Okay, so the very first one I'm looking at, angle 1 is 90 degrees because diagonals inside a rhombus are perpendicular. Angle 2 and 3. These two angles are congruent because the diagonals bisect the angle it comes to in each side. So, but because opposite angles are the same in a parallelogram, if this is 58, so is this, so is this, so is this. That's why these are what they are. Okay, you all right with that? Now that other side, angle 4. If I know the measure of angle 1 is 90, I know this is 58. This is a triangle, and it's a right triangle. So 58 plus the measure of angle 4 must be 90. Or I can look at it as, oh, that's 180. I don't care which one you want to do. Okay, but I'm going to take 90 plus 58, which is 148, subtract it from 180, and the measure of angle 4 is 32. That's all I did. Okay, so I'm using the properties that we've got from rhombus to get this going on. Are there any other questions about this? Okay, we doing okay? All right, so let's check this out on this next one. Now here, a parallelogram is a rectangle, then its diagonals are congruent. Now this is pretty cool, and this is something that makes kind of a lot of sense, because if you consider A and B, and you have the value C, these are all lowercase, this is Pythagorean theorem. Okay, it's a right triangle, it works, and we're talking about diagonals being congruent. Well, if I have those and I'm talking about this, Isn't this A and this B? So therefore, I've got two right triangles that have the same leg measurements. So they should be the same length because of Pythagorean theorem. This is C, and so is that. So remember, A squared plus B squared equals C squared. So it totally should work the same. In a right triangle, I've got the hypotenuse the same, and in the hypotenuse, we're talking really about the diagonals in a rectangle and therefore square. So with this information that we know, and by the way, I'm not using Pythagorean theorem to find these. I now know that the diagonals are congruent because I was told, but it really stems from Pythagorean theorem. And 3, if I know that this is a rectangle, they tell me, I further know that SF and RB are the same because those are the diagonals. They give me relationships on SF and RB, so substitute and solve. Go for it. Substitute and solve. Hopefully, you're able to subtract 2x from both sides and then add 12. You get 27 equals 3x. Dividing by 3, we get 9. How did it go? Now, as in every geometry question you ever answer, reread the question. Because we have the right solution for x, but did they ask us to find that? Ah, darn. We have to have x, but we're not quite done. So we got to plug that back in and find out that it's 33 apiece. Okay, and people are like, how did you find that? Because I took, excuse me, 2 times 9 plus 15, that equals 33. That's SF. And I took RB, 5 times 9 minus 12 is also 33. So I needed to do that in both instances, okay? Just to check, make sure I'm doing it right. I'm on the right track. It's your turn. Go ahead, check it out. Yep. Go ahead, get her done. Get her done, get her done, get her done, get her done. I'm gonna do the cable guy thing. Just get her done. All right.
I'm so scared.
I know. You should be. Are you okay? Right there. Did you plug those in? Did you set those equal? Now, solving, I'm hoping at this point we're at 15. Okay, I plugged that 15 back in. I'm finding that I got 43s. Remember, M, O, and Ln are equal. So if I go 4 times 15, which is 60, minus 17, I should get a 43 for Ln. Ln. And then for MO, I should be getting 2 times 15, which is 30, plus 13, which is also 43. And I should be golden with my answer. Okay? It's really moving slow today, slower than I usually do. Now, things you know about the diagram. What type of shape is 5 right off the bat before you even start approaching it? After you read the, what? I didn't hear you, Yang. What was that? Rhombus, okay, but before I even start, I got a parallelogram, right? Are you okay with that? And we're supposed to decide if each parallelogram is a rhombus. How do you know it's a rhombus right off the bat? Angles aren't 90, so it takes out a rectangle, takes out a square, and Congruent sides. Every side's the same. So those are the things that I've got to look at. It's a rhombus, and he's right, 100%. It's a rhombus because the sides are all congruent, okay? But then he checked the angles, and that's the biggest thing. Because although it is classified as a rhombus, if you have a rhombus that's right angled, interior angles, that's a square, okay? The right angles, interior angles also classify that square as a rectangle with the information we know. But because all the sides have to be the same to be a square, we want the most specific name as we go through. So nice job, Ms. Yang. Okay, next. What's the next one? Why? Because I said so. What? Say it louder. How do you know all the sides are congruent? I just have two of them. And opposite sides in a parallelogram are congruent. So because of these two, I know these two automatically. Automatically. So yes, I got all the sides are the same. But what do we know about angles? Opposite angles are congruent. Consecutive angles are supplementary. So it has to be a square based on all that. Okay, so we have to make sure we have supportive evidence of properties to help us figure that stuff out. Okay, now with that information, we got a self-quiz on problem 7 and 8. See if you get it. Go. See if he gets it. Go, 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 go. See if he gets it all. Okay. What do you know about angle 2? Right off the bat, just looking at it. Mr. O'Hare. It's 90 degrees because the diagonals in a rhombus are perpendicular to each other. Okay. What do you know about angle 3? Why? Okay. Make the whole angle. The diagonals bisect each angle it comes to. So if one's 50, the other one has to be 50. Okay, so we know those two right away looking at that. Now we got a right triangle inside this rhombus that's set up. In this right triangle, I'm really talking about this right here. This is 90, this is 50, and now angle 1 and that 50 degrees have to add to be 90 degrees according to right triangles. The acute angles have to add up to 90. So what do we know about angle 1? It's 40 degrees. Okay, so we kind of cycle through, and we're using triangle sum theorem for that. Now, your turn, do 8. If you haven't done it already, get her done. Okay, your last one should be PS is equal to SR and Y is 3. Did I need to find anything else? No. So we're good. We got it made. We're okay. And we are ready to be on with our assignment. Now, before you get to your assignment today, I would like to have you guys take a 6-1 homework quiz that's available in your Schoology folder for Chapter 6. I have just opened that quiz to you so you can access it. So please take it in kiosk mode, okay? And it is inside your folder in Chapter 6. Then you access your Chapter 6 folder. It's in the 6-1 to 6-4 homework quiz, practice quiz section, and it's the very first one you got there. It's the only one that's available. Good luck, and we'll talk to you soon.